Hmm? So, okay. So once again, you are welcome to another segment of our class. So today we want to take a look at atoms, molecules, and ions as far as our class is concerned. Now, we said atom is the smallest particle of an element which can take part in what? In chemical reaction. All atoms that we have, they are found where? Where can we find an atom? Who can tell us where we can find atoms? Where are atoms found? We find atoms where? In elements, isn't it? Atoms are present in elements. Now, these atoms are responsible for the chemical reactions these elements undergo. Are you with me? So, if you have a particular, let's say element A, and you have another element B, reacting together, it is as a result of the interaction between their atoms that they are reacting. Nothing more than that. Are we together? So, in this case, that is what we said. Since atoms are present in elements, they are smaller than elements themselves. Atoms are what? Smaller than elements themselves. Okay? So, in this case, that is why you cannot say element of atoms. That is very wrong. Rather, you say what? You say atoms of what? Elements. Are we together? So, in this, atoms have electrons and protons. If, for example, let's draw a normal atomic structure. Inside, you have proton and neutron. This is the nucleus. Now, the nucleus is surrounded by what we call shells. Okay? Now, these shells or orbitals have electrons revolving around the what? The nucleus. So, this is the nucleus. And I say inside the nucleus we have what? Proton and what? Neutron. Now, this very particular one is known as your shell. Or what? Orbit. Now, these electrons are outside the nucleus. You cannot find these electrons inside the nucleus. Rather, they are found where? Outside the nucleus. Now, inside the nucleus of an atom, what do we have? Proton and neutron. So, an atom is completely neutral. By the time the number of electrons revolving around the nucleus are equal to the total number of protons that are inside the nucleus. Remember, what is the charge of the protons in the nucleus of an atom? Positively charged in this case. So the protons are what? Positively charged. Protons are positive, while neutrons are neutral. Okay? Neutrons are what? Neutral. They don't have charge. Neutral. Then electrons are what? Electrons are negatively charged. Is that clear? So, seeing the fact that, okay, negative electrons revolve around the nucleus of an atom, whereby the protons are positive, there will be attraction between what? The proton and the what? And the electrons. So, and if the numbers are the same with these charges, let's say we have 5 protons and 5 electrons. What do you expect? Plus 5 minus 5 will give you what? 0. That is neutrality we are talking about here, isn't it? We are talking about what? Neutrality. Because at the end, you will not have the numbers, you get 0. That is what we are saying. So, atom tends to be neutral. That is, it is neither positively charged or negatively charged when the number of atoms, when the number of protons are equal to the number of what? Electrons. Is that okay in that particular atom? And don't forget, we said that the protons can be found in the nucleus of the atom, while the electrons can be found where? In the shells or orbits. Is that understood? Fine. Now, in a situation whereby, as atom is concerned, when you have the number of proton be more than the number of electron in an atom, what happens? The atom becomes what? positively charged. So in that case, we have a cation. Now, a typical example. Let's look at the typical example here. Give us one atom that we can use to identify the number of protons being more than the number of electrons. Yes? Who can give us one example of an atom? Yes? Who can give us one example of an atom that we can use? Want to make use of hydrogen atom? Can we make use of hydrogen atom? Let's use sodium atom, for example, right? Now, let us look at sodium atom. Sodium atom, in this case, contains how